So let's talk about angle relationships. We're looking about how do angles compare in relationship to each other. The reason you need to know this is as you go on, especially geometry, for those of you, and there's a bunch of you in here that are going to become engineers, you need to know how angles relate to each other. So a line that crosses parallel lines is called a transversal. Parallel lines. These two are parallel lines. That means they run along the same slope. They'll never meet. I won't use that joke again. Are you proud?
No. Yes.
Hey.
Oh, man.
Okay, so when we do this, you'll notice when I cross these lines here, do you have a pencil? Okay. When I cross these lines here, I end up with a total of 8 different angles, don't I? 1, 2, 3, 4, 5, 6, 7, 8. So all these form. And if you look at them, I've formed on each side, there's one obtuse and one acute angle. Do you agree?
Yeah.
Remember, if it becomes a toy for other people, I take it away. You're trying really hard. Kaylin's doing really well at ignoring you. Okay, so now think about this. In this case, since they're parallel lines, every angle that's obtuse here, it starts with acute. Every acute angle here is congruent. Angle 2 is congruent to angle 3. Angle 2 is congruent to angle 6. And angle 2 is congruent to angle 7. What does congruent mean?
The same.
They're the same. So all 4 of those angles share the same measure. The same thing is true about obtuse angles. The 1 and 4 and the 5 and 6 are all congruent. They're all the same measurement.
The 6 is acute.
Did I say 6 or 8?
You said 6.
Sorry. The 5 and 8, they're all congruent. They're all obtuse. Now here's the next thing. Any acute angle in this, any of these acute angles, 2, 3, 6, and 7, is supplementary to any obtuse angle, 1, 4, 5, and 8. What does supplementary mean?
Equal to 180.
Equal to 180 degrees. Which means if you add any obtuse angle plus an acute angle from this set of 8 angles, you get 180 degrees. So if I asked you a question and said, which angle is congruent to angle 1? What are some possibilities?
2, 3, 6.
To angle 1, 8 is true. It's congruent, the same size. How about if I said which angle is supplementary to angle 1?
Equal 9, equal 8.
2 is a good choice. Is 3 a good choice? How about 6? How about 7? They all are that. So know some of the rules and how they match up. Remember, a straight line is 180 degrees. If you break it, you end up with 2 angles that are supplementary to each other. Let's look down here at some of these others that we're going to go through. The Triangle Sum Theorem says that any triangle, here's the triangle ABC, the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. And if you look, there's an example. So the measure of angle A is 78 degrees. Angle B is 64, and angle C is 38 degrees. If you add 78 plus 64 plus 38, how many do you get?
180.
180. A triangle always equals 180. All right, some other rules. 2 angles created when you bisect a line are called supplementary. We got that, right? We got that up there at the transversal, because anytime we bisect the line, we end up with 2 angles, and since they equal 180 degrees, they're supplementary. Does that make sense? What happens if the angles equal 90 degrees? What do we call them?
Acute. No, all right. No.
2 angles, together they add up to 90 degrees. What do we call them? What's the word? Who said it over here? Complementary. Right. Be 2 angles that add up to 90 degrees. That we are always complementary. All right. We'll let that fall there. All right. So, and this one comes a little later. When solving triangle similarity, what does similarity mean?
They are the same size.
No.
They have the same angle.
They have the same angles and the same proportions. All we're talking about is a proportional relationship. when you get that, I've got a problem here. It says a woman is 5.5 feet tall. Her son is X feet tall. The woman casts a shadow that is 3 feet plus 13.5 feet. How much is that? Yeah. How much is that? 16.5 feet. Now the boy, who's X feet tall, casts a shadow that's 13. 5.5 equals 5.5 over 16.5 equals X over 13.5. Remember this technique where we circle them and we multiply the cross? You remember seeing that on the board and using that a couple times? So 5.5 times 13.5 equals 16.5 times X. At that point, you can use NSolve, can't you?
Yes.
And it'll tell you what X is. Go ahead and ask your question. So remember, when you make a proportion, and that's all this is a proportion problem, that's all it is in the form of a triangle. The last one is angle-angle similarity. It says that if two angles in a triangle are the same, then the third angle matches in both, and they're similar. Yes, ma'am.
Okay, we'll go back one.
Okay.
Where did they get the 74.25?
Well, what's 5.5 times 13.5?
16.5.
What's 5.5 times 13.5?
74.25.
74.25.
Oh.
That is just simplifying that top. Yes.
Is there another way to do that?
There are many ways to do that. Ask me another time. So, and I told you guys before, and Carly's right, there are a ton of ways to do anything. And like Lizzie's talking through this whole thing right now, there are a ton of ways to do anything.
She just talked like 15 minutes.
I know. I will show you one or two ways. The reason being is it would be great if we could spend 4 hours a day together for a year. I could show you all kinds of techniques and we'd be uber smart. But you guys don't want to spend all this time with me. That hurts my feelings a little.
Wait, no, it's not you, it's the math.
Yeah, no one likes that.
But we can be friends. But the truth is, there is not enough time. Shh.
There isn't a star tag.
As you go along in your educational career and beyond, you will learn different techniques. And I say this because one of the last things I did in the Army was calculate the distance of incoming aircraft and missiles. And that used a formula that involved scientific notation and the speed of sound. Or speed of light, sorry. I never thought I'd ever do that kind of math. And there I was doing stupid math in my head, calculating where planes were. And they moved pretty fast, too. No, once you got doing it, and the more you did it, the easier it got. It's just because of repetition. So angle-angle similar. Look at these two triangles. They both have angles that are 82 and 41 degrees, right? Are they similar?
Yes.
Well, what's the measure of the third missing angle?
That's probably the same.
How would I find the measure of the third angle?
Well, you see, we would add those and then you would subtract it from 180.
So do that. Add them and subtract from 180.
Oh, I have a calculator.
You guys get it done over there.
Oh, yeah.
Add those two and subtract from 180.
It's like,
Or if you're like me, just take 180 and minus 82 minus 41.
it's 128 minus, what's 128? I mean, 122.
You're making me sad, like twice. Stop.
Is it
Use your
by
calculator.
180 or divided?
How much are all the angles inside a triangle equal to? 180 degrees.
It's 128.
So what's the remaining angle there? 57 degrees. Is it the same for both? Yeah, because they both have the same other. So all the angle thing says is, if I find two angles that are the same, then it's similar. Now, this one's pretty easy. Later on, we're going to throw variables in there, and you're going to have to do some math. By doing angle-angle similarity, you save yourself doing math for two angles. You only have to find two on each that match, which means you can skip some of the math. Does that make sense? Any questions? And that's an overview. We're going to go individually, one by one through them. Any questions so far? Good. Let me pass out some.